All right, cool. It should be live now. Awesome. Great. Thanks everyone for tuning in. I'm glad that you all can make it. I'm doing another little programming live stream here today. So yeah, today we're going to be talking about something a little different. So for those of you who've been here for the past few weeks that we've been doing this, I've mostly been working on a new plugin that I'm developing that will hopefully be out sometime later this year. And today I wanted to talk about something a little bit different that's a little bit more I don't know, experimental, just something that I'm trying out. Isn't really going to be released in any way anytime soon, but it's just something that I'm interested in and kind of wanted to talk about, and that's developing plugins with this newish programming language. So this is the Jai programming language. So Jai is a bit, it's pretty new. I think development started in like 2015 or something like that. So the sort of, the language and the support for the language is, a bit less mature than something you'd see with even newer languages like Rust or Go or things like that. Certainly not what you'd see with a language like C++ or Python that's been around for, 30 plus years now. Yeah, and so today I just wanted to show a little bit of some stuff that I've been working on with trying to make plugins with Jai, and yeah, just kind of see what people think, and maybe get some ideas for other things that I could try. Yeah, I'm excited to show you guys around. So right now I'm just working on a pretty simple filter plugin. So this is going to be a state variable filter, and yeah, the idea is to make it all in Jai. So right now I've just got a simple audio processing loop that currently is doing nothing, but maybe as we go along today we'll fill that in with some real stuff. We've also got some parameters which we can take a look at in a second. Yeah, so right now we've just got a frequency parameter, and I'll probably make a function to initialize all of our parameters. But right now, we're just making our frequency parameter called cutoff. It's going from 20 to 20,000 hertz and has a default at 1 kilohertz. So I'll show you all how we're going to compile this here. So I've got a little folder where I'm doing some stuff here. So just called clap, and all I have to do is Jai build clap, and that will build it. Builds are pretty quick. This one was maybe a little bit slower than most of the ones that I've seen, but takes about a second to build the plugin. So that's a nice improvement from C++. And then what I've been doing actually is using the clap info tool. I forget who wrote this. I think it might have been Bacon Paul who wrote this, but it's just a handy little tool for taking a look at like what information you can know about a clap plugin without having to, actually do any processing or save and load state or anything like that. So I'll show you what we can do here. We can do build, release, clap info, and then I'll point it to the plugin that I just built. So it's called SBF clap plugin. And right now the build script is exporting a DLL. At some point I need to figure out how to get it to rename that to a clap. But for now, at least with clap info, that doesn't matter. So if we look through the results here, we can see a bunch of logging information that I'm getting out of the plugin. So I can basically look through the clap extensions that are being queried. So the plugin will ask the host about various extensions, and so we can see what extensions the host supports. For clap info, it's not a ton, just because it's a little test app. It's not actually meant to do anything. And then we can see when the host queries the plugin for extensions. So we can see that it's asking about parameters, and the plugin supports parameters, so that one's cool. asked about audio ports. The plugin supports audio ports, so that's cool. The host asked about node ports. Right now, the plugin doesn't support node ports, so we're just going to say that it's not found and go from there. And then we can see, some basic info about the plugin. We can see the description, the name, the plugin ID, all that kind of stuff. So yeah, that's sort of the very basic information that we're able to get from this. Oh, interesting. Okay. Yeah, I guess I should also explain sort of the development environment that I'm using here, because it's a little bit different from what you're probably used to seeing me do. Basically, right now the Jai compiler is only, at least the version that I have, only works on Linux and Windows. So I'm actually developing on Windows, but I didn't want to move all my streaming setup over to my Windows computer, so I'm just doing it through this VS Code remote thing. And yeah, it looks like that sort of got messed up in some way, so I may need to restart it here. Yeah, maybe let's try restarting the server here. All right. Yeah, so anyway, while that's getting set up, I can actually show you all that the plugin is functional in Bitwig. So yeah, again, this is just working through my Windows computer. Anyway, I'll let this start up because yeah, we'll need to do some testing with this soon, so it'll be good to have it up and running. Hey, Jamie. Glad that you could make it. All right, let's close up some stuff here and look at clap plugins. So this is the Jai clap SVF. And as we can see right now, we've got our basic cutoff parameter, and that goes from 20 hertz to 20 kilohertz. And yeah, it's pretty straightforward, nothing too fancy or complicated or anything like that. And yeah, let's see if we can get our dev environment back up and running. There we go. All right. Cool. So I think the first thing I was going to do is add another parameter for the resonance of the filter. So let's take a look at how we're doing that. So yeah, as I mentioned, right now we've got a struct for our parameters. So kind of a interesting thing about Jai is that there are structs, but there are no classes. And unlike in C++, structs cannot have functions. So functions are all sort of free functions, and then structs just have data in them. And I'll show you what this looks like in a second. It's actually not as, like when I first heard that, I was like, oh, that must be, pretty bad, because then, you can't have member functions, but you sort of can have member functions. And I'll show you guys what that looks like in a second here. So first, let's make a new parameter for the queue. And this will just be a float parameter. And then we'll make a sort of a member function that would be basically like the constructor for this struct. So we'll call this init params. Oops. Init params, and the function will take an instance of our struct here, and it will initialize it. So we can do params, SVF, plug in params, and now we have a function that can initialize our parameters. And so the trick with Jai, the way that you get sort of a member function behavior is through this using keyword, which shows up in a lot of places, and there's a lot of reasons for that. But if we put using here, then that basically makes this similar to a member function in C++, because, you know, we could do like params dot cutoff parameter, and then, you know, something, just like with, you know, any regular function that has public data, or sorry, any regular struct that has public data. But the way that you get sort of a member function behavior is you do this using keyword, and now the params dot part of the name is assumed, so you can just do that and do what you need to do. So let's move a little bit of our logic from here over to here. So basically what we're doing here is we're initializing our parameter, we're giving it a name, we're giving it a range and a default value, all that stuff. And then we're doing this register param thing here. And register param is going to basically tell the host that, hey, this is a parameter. It'll register like the parameter info with the host. And so that kind of takes care of business for us that way. There actually may be a slight bug in one of these that I need to take a look at in a second, but we'll get to that soon. So now we're going to want to do the same sort of thing with our Q parameter. So first of all, I don't need that because now we're in this sort of member function-like environment. And yeah, let's do our Q parameter here. So we'll call this, I don't know, filter Q maybe. And let's see, our maximum value, or sorry, our minimum value, we'll do like a half, maybe, I don't know. Our maximum value, maybe we'll do 10, and then our center value maybe should be 1. And for our default, we'll do the usual 1 over the square root of 2. I don't know, maybe that's good enough. Oh, cool, it kept our terminals for us. So now we can build the plugin here. I guess we've got a slight problem. Okay, so we've got like a name shadowing issue here because there's already something called params in one of these higher level things. So I call this plugin params. Not a big deal. And now what do we got? Okay, so mismatched levels of indirection, wanted type params, given type star SVF plugin params. Interesting. Okay, so let me look at what register params is supposed to do actually. Yeah, actually, I guess I should talk about this too. So what I've got here is basically bindings for the clap API that are written in Jai. And then what I've got here is my own little like mini plugin framework that's all Jai based. Yeah, I mean, it's very bare bones right now. It's not anything like you would get with like Juice or iPlug or NIH plug, but you know, maybe I'll build it up into something more usable. Oh, interesting. Okay, so what I've got here is I've got an array, I've got my params. Interesting. So I think I actually want this to be a pointer. So the way you do a pointer type in Jai is you do a star before the thing, and that means pointer to params. And then I don't need a pointer there. So I think that was one problem. And then here I already have a pointer, so I don't need to make another pointer. So yeah, just a little bit of indirection stuff. Okay, what did I break this time? Type mismatch, wanted type, pointer to array, type given star, params base. Interesting. What did I do? Interesting. Okay. So params is this type, which has a param holder in it, and param holder is has this params inside. So okay, what did I do wrong? Param holder params. So let's try this again. So we want plugin params dot params. Oh, okay, so we still need the pointer there. Yeah, that's maybe a little confusing. I wonder if maybe there's a way to clean that up. But yeah, I mean, all of these things are, this is a unfinished programming language. It's still a work in progress. So, there's all sorts of things that are still being ironed out. And I guess that's maybe a thing that can be improved upon. So maybe I'll make a note of that. But yeah, so we were able to get that to compile. So we should have 2 parameters now. I just need to actually call the constructor here. So I'll do init params, and this will be, I think it's just called params. Let me double check that. Params, okay, and that's already a pointer, so I shouldn't need to do another pointer, I think. Let's see, what did I do wrong? Okay, maybe that is supposed to be a pointer. Let's see. Interesting. Okay. So we've got our, oh, I see. I was looking at the wrong thing. I don't want to see SVF processor. I want to see SVF plugin. In an SVF plugin, the params are not a pointer. So that makes sense. Okay. Plugin init. I wonder where the scroll bar is. Oh, I see it's getting cut off on the side there. Okay. Let's make that a little bit smaller. Okay. So now, yeah, now that should compile. Cool. So let's see. Yeah, so we have a bunch of stuff to initialize here. We initialize our parameters. We initialize this audio thread context, which I can talk about that in a second. That's a whole other sort of interesting world. I think that's how we want it organized. That makes sense to me. So yeah, we've got our plugin compiling, and then let's see if I can actually run this. So we'll do SVF. Clap SVF plugin. Use the same. I'll use the same path there. Okay, cool. So now we should be able to reload Bitwig here. And we should be able to see the plugin now with 2 parameters. Yeah, there we go. All right, so we've got our cutoff and we've got our filter queue. So what's bugging me is that when we initialize the plugin for the first time, both of the parameters are at their maximum value. We want them to be at their default value. So that's the bug I had mentioned a minute ago. That now we're going to try and fix. So yeah, let's take a look here. Yeah, any questions so far? People curious about Jai or curious about other things that might be interesting? Hey, Chris, how's it going? All right, yeah, so we've got some current value here, and the current value is not in the normalized range. And so when we go to get the value, interesting. Okay, so when the host asks for the value, we're giving it the value of the unnormalized. Yeah, we're giving it the unnormalized value. That doesn't seem quite right. I think I flipped these. I think this should be convert to, because we want to get the host, we want to give the host the normalized parameter value. And then here we want to denormalize the parameter value before we start using it. So let's try that. Right. Yeah, that looks right. Okay, so now we've got our default values set up, and that seems about right. If we go to our default value, that's the right value. All right, cool. So now we actually get to do some signal processing. That'll be fun. Now that we've got our parameters set up, let's go ahead and actually do some DSP. So let's see here. We've got this SVF processor and process SVF that we probably want to move somewhere that's not in this file, just because this file is getting a little crowded with some other stuff. So let's make some new files here. First one, let's call it SVF processor. I think that's the name of the class there. And then I wonder if we need another file for the actual DSP. Yeah, maybe let's do that. So this will be DSP SVF. And yeah, I'm going to go ahead and pull up my existing SVF implementation just to have as a reference. So this is a state variable filter that I got from a paper that Andy Simper wrote. So if you're familiar with Andy's work, then some of this will probably look familiar to you. And if not, then, well, now you get to see some of Andy's work. He does some great stuff. So hopefully that'll be useful as well. So we've got a state variable filter. We've got a few different types. I'm not going to worry too much about type right now. I'm just going to assume that we always want low pass, and then we can, you know, make it a bigger deal later if we want. Okay, and yeah, we've got like a ton of stuff here, but really what we want is the data here. So we want our sample rate, we want our state variables. This stuff is specific to some of the different modes of the filter. So let's just stick with this for now. SVF. Well, I flipped it. Should be SVF struct. Cool. And then I guess we want this to be like in C++, we would call this a templated class, because we have some sample type, which could be a float, it could be a double, it could be, you know, something else. In Jai, they call that polymorphism. So we would have sample type, sample type, and this would be a type parameter. So, you know, you could also have like a some other thing that would be like an int parameter or something. But in this case, we just want a type. So now we can have our sample type in here. So let's recreate these in this struct here. So we'll have our cutoff frequency, which is of type sample type. Don't do that. We'll have our resonance, which is of type sample type as well. We'll have our gain. I don't know if I need gain in the current implementation because I'm only doing the low pass version. But I don't know, maybe it's important. Then we've got some, well, yeah, I guess I should keep my comments here just to keep things tidy. So then we'll have our parameter intermediate values. I think there's a way to do multiple initialization like this in Jai as well, but I don't actually know it. So I'm not going to worry about it for now. So we'll do, well, I don't know. Maybe I don't need this stuff at the moment. I'll come back to it if I need it. We will need the coefficients. So we'll have A1, oops, A1, A2, A3, AK. And we'll have, yeah, I guess these other two. So K0A and A square. I'm not sure we'll need all of those, but you know, whatever. Okay, and so now this is where things get kind of interesting. So in my C++ implementation, I use a vector here. I don't love having a vector there, but maybe I'll just keep it the same for now, just to keep everything consistent, you know. Yeah, let's just do that. So in Jai, we'll have IC1 EQ, and this is going to be a variable length array of type sample type. Oops. Sample type. And yeah, these are our state variables, so I'll copy that. And then we'll have our IC2 EQ for the other state variable. So the only thing we don't have right now is these parameter intermediate values that I'm not 100% sure we want. Oh, and then I guess we also need our sample rate. So let's do sample rate. Should I keep it as float 64? Yeah, keep it as float 64. And then this will be 3400. Cool. And then from SVF processor, we can do import file DSP SVF and get our file. And then in the plugin, we'll want to import that. I'm using load here for reasons which I can talk about if people are curious, instead of import. But yeah, that might just be something that I'm not understanding right, and there's a better way to do it. So I'm not going to focus on that right now. And then kind of another neat thing in Jai is that you can have what they call a namespace here. So we'll say SVF is the stuff that we're importing from that file. So let's see if that builds. Yeah, what happens? I just want to make sure that I am actually building this stuff. So I'm going to make sure that it doesn't compile if I make a mistake. Okay, cool. Oh, okay, Jamie wants to know, how does the clap wrapper work, or interop support in general? So interop support in general, I'm not 100% sure how it works. I've only, like, the only thing I've done as far as interop with Jai is the clap wrapper, and that's just interop with C. So I can show you how interop with C works. Maybe with other languages, there's other things that you can do. But basically, it's actually really simple. So I'll show you guys the original clap API. So this is just the clap API written in C, and let's look at process maybe. Well, yeah, okay, this is fine. So basically, well, actually, maybe this isn't a great example. Let's look at events. That'll be a better example. So in the clap API, you kind of have three things. So you've got these structs, which are just plain data. You've got these enums and some other constants and stuff like that. And then you've got some structs that have function pointers. So for example, yeah, this is a good example. So you have a list of input events, and those all go in a struct. And then from the list, you can query how large is the list. So that's this size function here. And then, there's some C. There's like a C++ wrapper that you can use around all of this so that, it looks more C++ like. In the Jai version, it looks very, very close to the C implementation. So we say, okay, we have a struct, it's got the data. we make sure that all the data types line up. We can have our enums, that all works the same. We can have our constants, that's all the same. And then when we need to do a function, it's actually very simple. So the size function that we were just looking at becomes this size function here. And this is actually a function pointer. So we're saying that this struct has a pointer to a function that takes in an argument that's a pointer to this clap input events t, and it returns a unsigned 32-bit integer. And then we just have to mark that it's a C call, and that just tells the Jai language that, hey, don't do anything to this function that would make it incompatible with calling from C. And there's a few things that means that are specific to Jai, but for now we'll just say that it makes it compatible with being called from the C language. So yeah, the writing the bindings was actually pretty straightforward, because you can kind of just look at this and say, okay, we have a function called size. It returns a uint32, and it takes in a const clap input events pointer. The one thing that is weird, and I don't know how I feel about this, is that in Jai, there's no such thing as const. So this pointer, I should probably add some comments and stuff just to make sure people know that it's supposed to be const. But you know, for right now, that's just kind of how I have it working. So yeah, I was basically just able to look at the clap headers, rewrite them in Jai, and yeah, translate all of the data types and function types as needed. So yeah, it wasn't too bad to get the wrapper working. And then in my little framework here, basically I just have a plugin base, and this is basically similar to what you would see in like the clap helpers repo or something like that, where basically, I have all these function pointers that I just have to initialize to the correct pointers that live somewhere. These are just functions that live somewhere in my program. And in this case, plugin init is right here. And so that's our clap plugin that we would see here, for example. So in our clap plugin, we have some init function that's, a bool, and it returns a bool, takes in a clap plugin pointer struct. And then in our Jai implementation, we just say, hey, set the init function equal to this plugin init function here, and that'll take care of everything that I needed to do. So yeah, that's the basics of the wrapper. For more general interop support, I mean, as you can see, calling to or being compatible with the C interface is not too complicated. If you wanted to do something more involved, like compatibility with C++ or another, more complicated language, then I would imagine there's some other, maybe some other things that you would need to do. But I haven't gotten that far myself, so I'll get there. I'll get there when I get there. Cool. So we've got our SVF struct here, and so let's have a few functions for it. So we'll have a prepare function. So I'm going to do this in sort of a juice-like way so that people recognize it, and maybe that'll be simpler for me too. So this will be like a member function for the SVF class. So we take in an SVF, we take in a sample rate, we take in a, do we need a block size? I don't actually remember if we need a block size for this class. Let's see. Prepare. Okay, looks like we don't need the block size. We do need the number of channels though. Okay. Hadn't thought about number of channel stuff yet. That's going to be annoying. The Zoom header is kind of in the way there. Anyway, so we'll do channel count. And that should be all we need. Then we'll have a reset function. And then what else do we need? Maybe we'll just do a process sample function for now and live with that. And then maybe we'll figure out later exactly what we want to do inside that. Like maybe if we wanted to do like a process block kind of thing to maybe, make things a little bit faster. Okay, William wants to know, what is SIMD support like? So I'm not super sure yet. Maybe I haven't spent enough time looking at how to do things, but from what I've heard, the way that you would write like SIMD instructions is you would just write Jai supports inline assembly. So you would just write like an assembly block that calls your SIMD instructions directly from there. I don't know exactly what that looks like yet because I haven't tried it. But I imagine it would be possible to make like a little SIMD library similar to what you might find with like XSIMD or SIMD PP in C++. That kind of wraps the things you need in kind of a nice little type safe and whatever wrapper. But yeah, I haven't dug too deeply into SIMD support, but that is something that I'm meaning to do. So yeah, thanks for the question on that, because that also reminds me that I need to do it. Oh yeah, and then I need to have some functions for setting the parameters. So let's add that. So we'll have a cutoff frequency. Oh, you know what? I've been forgetting my type parameters here. So we'll have our sample type here. And I'll just call it T for now, just so I don't have to type sample type too many times. And so this should be of type T, I believe. And then we'll have our Q value will also be of type T. And then finally, we'll have process sample. So this will be, we'll have our input sample X, which will be of type T. And then we'll have our, what do you call it, channel index. Okay, well, saying, seems a bit dodgy. My understanding is that assembly is discouraged at this point because it doesn't let the compiler do register allocation as effectively. Yeah, that's a good point. Yeah, so that's something that I still need to experiment with and try out. But yeah, that could be an issue that might make it difficult to write, effective DSP code in Jai. So yeah, as I mentioned at the beginning, this is just something that I'm trying out. I think it'll be cool. Maybe I'll like it, maybe I won't. Maybe I'll end up writing code for years. Maybe I'll stop writing code in 2 weeks and I'll never use the language again. But yeah, we'll find out. We'll see if it's useful for doing the kind of work I want to do. But yeah, that's a good point. Maybe having more tightly integrated SIMD support could potentially make this language a lot more usable for doing audio DSP. Yeah, that's a very good point. All right, so let's see here. So we want to have our prepare function. So yeah, we're going to need to set our sample rate and then resize our state vectors. So let's go ahead and do that here. So we've got, you know what? I'm just going to make sample type. I'm just going to make sample rate be of a sample type as well, just to make my life easier. So sample rate should equal fs. Oops. Yeah, sometimes I don't like these autocomplete things. Anyway, So for resizing an array, I actually don't remember how to do this, but I'll go and see where it's implemented. And there we go. Okay, array resize. So I want, yeah, I want this. Okay, and it's going to be initialized to 0, I guess. Probably. We'll find out. So let's see, we want array resize, and this should be IC1EQ, I think, and we want the size to be, I think it was an S64 that we wanted for channel count. Yeah, S64. I wonder why that's assigned int and not an unsigned int. Interesting. And then we'll do the same thing for IC2EQ. And then we don't actually need to call reset here because this will initialize to 0. However, we do also want to implement the reset function. So I wonder what this init range function does. Okay, so it's gonna initialize to 0. I don't know that I want to do that exactly. Is there like a fill function? No, okay. Yeah, maybe init range is the best I can do here. Yeah, maybe there's just some other functions that I haven't found yet. That's pretty possible as well. Oh, interesting. Okay, so it's going to initialize. It's going to initialize the new data, and not necessarily the old data. Okay, so I probably still want to call reset on the SVF. Oh yeah, yeah. Jamie has a good point about Rust having some good SIMD support. Yeah, I was looking at. I spent some time with NIH plug that I'm completely forgetting the name of the fellow who develops it. He does some great work. But yeah, he's got some really nice ways of using SIMD and going back and forth from scalar data types to SIMD data types in Rust. So yeah, if you're curious about this kind of thing, definitely check out NIH plug. You can get a lot of neat things out of it, and maybe get a really nice introduction to Rust as well. Yeah, definitely some really cool work. So let's see, init range. I want to init. Let's see. IC1EQ data from 0 to IC1EQ count, I believe is the way that I want to do that. So yeah, let's see. So now I can actually make my SVF processor, which I had started doing here. But I'll move this over to here for a second. And so I want my filter to be of type SVF.SVF, I think. Yeah, because I did SVF all caps like that as well. And so then I want some init processor function. Let's see, how do I want to do this? I want to do using processor is a SVF processor. I'll do sample rate, which will be a float 64 here. I'll do block size, which is a U32, I guess, and I'll do channel count, which will also be U32 for now. Cool. Maybe this should be max block size just to be a little more descriptive. And then I should be able to do, well, this should be SVF dot, what did I name this function? Prepare. Yeah, maybe this should be prepare processor just to keep things consistent. Okay, so we're going to prepare our filter. Oh, and I need to give this a type. I'll make this a float 32 just to keep everything 32 bits since that's what we've got here. Yeah, so we've got in process SVF, so I'll keep that consistent. And so we want a float 32 of our sample rate, and then we want our channel count. And now I actually want to call that, so I'll do that from somewhere down here. Yeah, here we go, activate plugin. So I want to do init, not init, prepare processor with the what did I actually name this type? Audio processor, that's the one. Audio processor, and then we'll have the same sample rate and max block size. And for channel count, I'm just going to say 2. I think there's a way to get that programmatically, but I'm not remembering it at the moment. Anyway, let's see if that builds. Does not. I made a mistake somewhere. Undeclared identifier array resize. That's because I didn't import that. All right, what next? Let's see, reset. Oh, undeclared identifier init range. Maybe that's like an internal that I'm not supposed to use. Yeah, so this is in this scope file, under the scope file mark, which means that I'm not supposed to use it. So that's okay. I'm going to search to see if there's a fill function. Fill array. No, that's just like a test function. Well, maybe there is, but I don't know it, so I'm not gonna bother with that at the moment. Instead, I'll just go with simple mem copy. So yeah, or mem set. Let me remember the syntax for mem set. Yeah, okay, mem set value 0 times size of times size of t, I think is what I want. Yeah, and then we'll just do the same thing for state number 2. Okay, I think that's what we want. Cool, so that compiles. That's a good sign. All right, so now we actually want to be able to set our parameters, which let's see how we want to do that. So from here, we're going to want to call svf.setParameters. Dot parameters. And this will be on self dot. Well, actually, we have using here, so we can just call this directly on the filter. And then our cutoff frequency is going to be our parameter that we had here. So cast float 32, our cutoff param current value. And then let's see, for the resonance, for the Q value, we're going to do the same thing, but with the Q param. Oops, Q param. So I think that should work. Maybe not. Set parameters. I spelled it wrong. There we go. All right, so that's fine. So now I just need to implement the internals here. So again, I'll just copy my existing implementation. So I'm going to need this, and then I think I've got some other code somewhere I'm going to need to copy. Also, it's really interesting watching the way you structure your processing code. I tend to write everything single sampled, but the process functions are static inline. Yeah, so this is something that I don't really know how I'm going to do this in Jai if I end up getting there. But the way that I typically do things in my C++ code is I try to have both a way to process per sample and a way to process per block. And there's a few reasons why the block approach is helpful. Maybe this is in the other file. But this is actually something I was talking about a couple weeks ago, is that like if I have some pretty much static inline per sample function here, but if I need to be reading and writing to some class data pretty often, I can pull out the class data just into like a little register basically. And then that ends up being a bit faster. Yeah, I don't remember 100% why. I remember Eyal Amir explained it to me a while ago. I should go back and I think he gave me some ideas of why that is, but I don't remember them off the top of my head. So anyway, let's go ahead and implement this here. So GK is just going to be temporary. That will be G plus K. Actually, first, let's figure out where our G and K are coming from before I get too deep into that. So probably from here, right? Yeah, so we've got set cutoff frequency and set resonance. This will give us most of what we want here. Okay, so maybe I don't actually need the cutoff frequency and Q parameters. I'll ignore these for now. Yeah, they might come back later. So let's see here. We want this W, or maybe it's supposed to be omega, to be equal to pi times the cutoff frequency, so that'd be FC, divided by the sample rate. We already have sample rate in the right type, so I don't need that anymore. And then now we just need to figure out where pi comes from. Yeah, so this should give you an idea of how little time I've actually spent in this programming language so far. I don't actually know where pi is defined. I'm guessing it's in this math module somewhere. Okay, there we go. We've got pi and we've got pi 64. So let's import math, and I'll do that under a namespace as well, just in case. So this will be math.pi times the sample rate times cutoff frequency divided by sample rate. This will probably be math.tan, I'm guessing. No xsimd here, so let's ignore that. And we'll want the resonance stuff, so I'll just copy this as well. So I don't think I need to cast to a certain type. I think it'll just infer that for me, but I guess we'll find out. Okay, K0 times A. What is A? Where does A get set? Interesting. Yeah, I don't remember where A comes from exactly, but I think it's just going to be 1. So yeah, I'm going to ignore that for now, and maybe I'll put a comment here to remind myself for later. Oh yeah, and then these are all temporary, so I need to make sure that they're defined here. So the way this works in Jai is if you do :equals, that means, and it like declare the variable here and set its value to this. You could also do like double colon, which is like, that's a constant. So like in C++, we would say like const expr or something. But in Jai, you just do : instead of :equals. And something that's kind of neat is that that's actually the same syntax you use for defining your functions. So I'm saying my function equals all this stuff. And this is like a constant function, which like almost all functions are. I guess there's a couple that aren't, but I don't think we'll get to that today. Anyway, so A1, these are all going to be class variables. Let me remember that. So K0A is a class variable. So I can't define it twice. And then all these A values are class variables as well. All right. So all of that I think is fine. Well, let's find out. What did I do wrong here? Error pi is not a member of import math. Really? That seems unlikely. What did I do wrong here? Oh, okay, I've got VS Code problems again. Hopefully this will clear itself up in a second here. All right, maybe not. I'll try a refresh here. Cool. Yeah. Any other questions while I'm waiting for this to reset here? Oh wow, that's pretty quick. Oh right, so that was the thing we were trying to deal with was okay, it's pi in caps. Nice. Oh, I guess they have tau is 2 pi. Is that like a common thing? I haven't heard that using that name for 2 pi before. Anyway. Undeclared identifier G. What is G? Okay, G equals G0 and K equals K0 over A. Yeah, maybe I don't need some of these extras. Maybe that's okay. All right, so that's fine. So yeah, these two I probably don't need since I'm only doing the low pass case for now. That's probably all right. Anyway, let's take a look at the process function. So if I go to process a sample, oh man, okay. So I have to do process core and then return v2 basically is all I want. So where does process core live? Process core is here. And yeah, again, this is all just like Andy Simper's derivation that I rewrote. I think his paper does it in Mathematica or something, so I had to rewrite it, but it's all just Andy's stuff. So if you want to go to the original source, you can find a link for that in a second. All right, so we've got some state. Okay, so S2 should be equal to IC2 EQ indexed at channel index. And same thing for S1. Oh, you know what? We actually want reference to that thing, don't we? Well, maybe not. Yeah, let's not do that actually. Instead, we'll do like a set here. Maybe that'll be, I don't actually know if that will be better or worse, but we'll find out. Okay, maybe I shouldn't have done that. I see one EQ of channel index is that, and then we'll do the same thing for IC2 here. Cool. And so instead of that, we'll just do return V2 for now for low pass. Okay. So now I think we're ready to actually process some audio. So let's do that here. Cool. So we're iterating through our buffer, and we're going to do svf.process process sample. And let's see, so we're going to process sample through the SVF with sample X and channel index. So this should be our filter. This should be our input sample. And our channel index is CH. Oh, and I think I forgot to mark that this returns a value. So I think I can do it that way. All right. Maybe this will work. We're gonna find out here. This is always the moment of truth, right? Keep the copy command. There we go. All right. So let's try some stuff here. So we've got our plugin, and maybe let's have a little bit of white noise just to test this out. Let's see, white noise and spectrum analyzer. Okay. Let's make this a bit bigger here. And yeah, I don't like the bitwig tilt that it does for its frequency analyzer. But yeah, it seems to work. Cool. Can we get some resonance going? Yeah, okay, looks like we can. All right. Maybe I'll do the EQ curve analyzer just to see what we get out of this as well. Too many plugins. All right. Cool, yeah, so we've got our cutoff. We can do cutoff sweep. I'm not doing any parameter smoothing right now, so there's probably some weird behavior that you might see, but things seem to work. Things seem to work about right. Yeah, okay. That's a good sign. All right. Cool, yeah, so that's a state variable filter in Jai. All right, yeah. I still feel like I don't fully know what I'm doing in this programming language, but I still feel that way about C++ too. So, you know, what else is new? Cool. So maybe I'm just going to commit some of this stuff so I don't lose it. Oh, hey, Robert's here. Yeah, someone had just mentioned NIH plug. Yeah. Yeah, thanks for your great work on NIH plug. I really enjoy experimenting with it. Maybe next time I'll do, maybe next time I'm looking for a distraction from my regular plugin development, I'll do some NIH plug stuff on here. That'd be pretty fun. Yeah, I think Jamie had also messed around with NIH plug as well, so maybe he would have some useful things to say about it. Probably more useful than me since I've only scratched the surface. Anyway, let me also make sure that I've got some stuff committed to the other places I've been keeping my code. I think this one's up to date. And this one probably needs a few things here. Anyway, yeah, so maybe next I'll try to get parameter modulation working. That sounds fun. Yeah, maybe let's do that. Let's do some parameter modulation. So let's see, I've got set value and get value, and then I'm using them somewhere in here. Let's see, so yeah, so here I call set value, which actually does this here. Yeah, so I probably should change the way I'm doing this. So the way I'm doing it right now, current value is in like the denormalized range. So for the frequency parameter, that's like 20 to 20,000. But that might get tricky when I add parameter modulation. So maybe let's not do that. Maybe let's change the way that we're doing this here. So now here, I would not want to convert to range, right? Let me see where I'm actually using get value here. So clap get info, I think. Okay, yeah, so let me see where I'm actually using this get value function. I want to match the whole word. Okay, get value. Oh, this is for the clap extension. Here, I'm setting it in here. Okay, here we go. So this is how I actually get the value. Yeah, okay, this is where I'm actually using it. So this needs to be in the 0 to 1 range. Yeah, that needs to be in the 0 to 1 range. So here, if I'm keeping current value in the 0 to 1 range, then I can just return current value. I think current value is part of param base. So maybe I don't actually need to, oh man, what did I just do? Okay. Yeah, I think current value is part of param base, so maybe it's fine. No, actually, I think that's false. I think current value is part of float parameter. Yeah, that's correct. Okay. And then here, I don't need to convert from the range there. I can just do that, and that'll be fine. Cool. So, maybe I want to rename some things here. So I'll do get normalized value and set normalized value here, just so that I can have other functions called get value and set value that will operate in the unnormalized space. Maybe I don't even want to set value for the unnormalized version, but here we can do this. And I'll just call it param get value instead of float param get value, and that way I can overload it. Yeah, that'll be a little bit easier. So oops, I don't do that. So we'll just have the direct param here. It'll be using, and then here we'll do convert from the 0 to 1 range. Oh, that's supposed to be a star range to, yeah, so convert the current value from 0 to 1 range. And then we're also going to want a get modulated value. So I haven't done any parameter modulation stuff yet, aside from just putting a field here called modulation amount. So let's think about how we're going to do this. I think the way that I do it in my my juice version is I just add the modulation amount to the current value. I clamp it into the normalizable range, and then I do the convert from 0 to 1 kind of thing. So let's do this. We'll say mod related value 0, 1 will be equal to current value plus modulation amount. And then I'll clamp that in the 0 to 1 range. And then I can do convert from modulated value 0 to 1. Okay, I think that'll work. And then the trick is that here, instead of calling current value, I need to actually get the values. So let's see here. Param get modulated value. And I'll just do param dot or params dot then param. Ooh, messed something up there. Okay, that one should be able to work like that. Okay, so I think that will compile, but it won't work because I haven't actually implemented the event processing yet for the parameter modulation. So yeah, let's come back to that in a second. Oh man, is VS Code crapping out on me again here? Hopefully not. Yeah, so this is my second day of trying to use this VS Code web interface. I don't know that I like it. I don't know, it seems a little bit, maybe a little bit slow than using it natively. Even natively, it's not always my favorite, but you know, whatever. But what do you call it? Yeah, the other thing is like syntax highlighting and code completion isn't really going to be there because, again, this is a very new language. So right now I'm just using the C++ code highlighting and whatnot. So it'll be a little bit weird. But yeah, anyway, it's fun to experiment with. Okay. Electropunk is a veteran programmer just getting into VST and KSP programming. Cool, yeah, I've never actually done any KSP programming, although I know a few people who do a lot of it. Maybe I should learn that at some point. Okay, why is my terminal not working here? Can I clear terminal? Interesting. All right, that's kind of annoying. Maybe let's just get rid of all the terminals here and make a new one. All right, come on. I just want to get parameter modulation working. I don't want to deal with this stuff right now. Yeah, I'll try restarting it again. Yeah, sure, reload. Cool. Yeah. I'm curious what your all thoughts are on Jai at this very early stage, obviously. Both of the language existing and of my trying to experiment with it and learn some things. All right, there we go. All right, so we've got a compiler error. What am I doing wrong here? Param get modulated value. Oh, I think I see what I did wrong. I need a pointer here. Oh man, this problem again. Come on. All right, one more time, and if this doesn't work, then maybe we'll just live in TeamViewer for a little bit while I try to finish this up. Come on. All right. All right, maybe this will work, maybe it won't. Maybe let's shut down Bitwig for a moment, and that'll improve things. I don't really know. Yeah, Chris knows. All right, let's just live in TeamViewer for a bit. Or I could just go with Vim. I don't know. Yeah, whatever. Let's see. Code. And yeah, let's make this big, maybe. If it'll let me. No, maybe it won't let me. Come on. Interesting. Okay. So now maybe VS Code is unhappy. Let's try to close a couple things here and see if that improves the situation. All right. Let's see. So yeah, like I had mentioned, currently the Jack compiler that I'm working with is Windows and Linux only. So I'm having to go back and forth between my Mac laptop or my Mac computer here, which is where I'm streaming from, and my Windows laptop over there, which is where I'm doing the development from, but that's okay. All right. Seems like we're in here. I don't know. Do I want to try doing Vim? I don't really want to do things over Vim, but maybe that's just where I'm at right now. All right, we're doing everything with Vim now. Let's go for it. Make things a little bigger there. Okay. Or I guess technically it's NeoVim, but whatever. I think I pretty much use it like Vim, so it doesn't really matter that much. All right, so let's see. I guess we'll do a second tab here. Can I split screen tabs? Maybe not. Okay. It's got to be a way to do this, right? All right, whatever. Wait, don't do that. Okay. There we go. All right. Sorry for the technical difficulties, but I think we're back where we want to be now. So there we go. So we've got an editor in one tab and what do you call it? Terminal I can build in the other tab. So that should be fine. So we're looking at SVF processor right now. And the problem we're dealing with is that these need to be pointers rather than ints. So let's see. There we go. Let's try that. Okay, we've got a problem between 64 and 32 bits, right, because the parameter value is 64-bit. The SVF is 32 bits, so we're going to want to do a cast here. Let's try that. Cool. All right, so that's working. What's the I'm forgetting the command again. Let's do this. So we want to implement our modulation event now. So this is where we want to do this. So yeah, here we go. So if our event is a param value event, then we know what to do, but now we want a param modulation event. So else if event type is a clap event param mod, I think it is. Let me see if I can remember exactly the name of the different event types here. So let's see, we've got yeah, clap event param mod. That's what we're looking at. Clap event param mod. Okay. Oops. So first we want to do our cast. So param event equals cast. This should be a pointer to a clap event param mod T, if I remember right. And then yeah, so we can use pretty much the same logic we're using for the param value event. So param will be a pointer to a param base. And then we'll want to do if param event dot cookie is not equal to null, then we can do one thing, and else we have to do the other thing. So basically the way that clap works is you can set a cookie for your parameter, and basically that will let you access the parameter directly through this pointer. Otherwise you have to look it up. I think most hosts support the parameter cookies, but maybe there's a couple that don't. So we have to have our fallback case there. So we've got a cast to the random base of our cookie if it is not null. And otherwise we have our lookup. So params dot params. Cool. So let's see how many mistakes we made there. Okay, cool. So not too many, but now we actually need to call our some function that will apply the parameter modulation. So let's see. for that, we'll need to do wait, no, that's a level up here. Yeah, that's going to be in our params here. So in param base, we have a get value and set value function, and then we have a set modulation function. So we're going to need to basically provide an override of the set modulation function. And then I guess, yeah, if it's null, then, well, that's another thing we'll have to deal with and have an idea for that. But yeah, let's see. So when we init the parameter, we have some things here. Okay, so yeah, so let's just add a function here that sets the modulation amount. So let's see. And then this will be mod amount, and it'll be a float 64. And now we can implement this. So we'll do the same thing we're doing above using param. And then we'll do modulation amount equals mod amount. Cool. And then finally here we need to do set modulation equals float param set modulation. I think that should work, but let's find out. Cool. So that's fine. And now all we need to do is clean it up on the other side. So here in plugin process, we need to actually call the function. Although I guess first we should check if it's null. But if it is null, then that probably means that the host is behaving, I guess. Yeah, let's do this here. So we'll do if param dot set modulation so if it's not null, then do something. Otherwise, we should say that the host is misbehaving. But I don't actually have a mechanism for doing that yet, so we'll come back to that later. And then here I can just call param.setValue. Param.setValue. So I'll call that one the param. And then the param event dot, I think it's the value. Let me remember here. Okay, it's called amount in that case. So amount. All right, let's give that a try. Cool. And then let me just double check. Let me just double check how I implemented. Yeah, let me just double check how I actually implemented the process function here. So SVF processor, I'm doing get modulated value. Okay, that should be fine. Let's find out. So let's see here. All right. So let's try that and see what we get here. Oh, here we go, cloud plugins. All right. Cool, so we've got our filter working as expected. And now let's try adding some modulation. We'll modulate the cutoff. Seems like it works. Maybe it's a little too aggressive. Well, yeah, okay, maybe there's a problem with it because it looks like we're down here near the bottom of the frequency spectrum instead of hovering around 1K. So we're close-ish, but not fully there yet. So let's see, get modulated value is what we're calling. So let's see here. Okay, so we're setting the modulation amount here. Then here we're doing current value plus modulation amount. We're clamping it in the 0 to 1 range, and then we're converting from our 0 to 1 range to our normal unnormalized range. So let's see, what are we missing? Maybe I'm modulating too fast. I don't know. Let's slow this down and maybe we can look at it a little bit better. Okay, maybe that's a little too slow. There we go. All right. Interesting. So something's off with our parameter modulation, because if we deactivate it, then what do we get? Seemingly we get approximately the right thing, right? More or less. Okay, so what are we doing wrong? Well, let's do this. So let's try, when we do our get modulated value, let's try just making that the current value and living with that for now. Maybe that'll get us there. All right. So what we're expecting to see here is that the modulation should have no effect on what the plugin actually does. So yeah, right now we're seeing our cutoff at around 1K, which is what we're expecting. And then when we add our LFO, we should get no change. Okay, so we are getting a change. That's interesting. Oh man, okay, let's just have a little bit. Okay, so for some reason the modulation is affecting the current value of the parameter, which is not what we want to see. So actually, let me remind myself how to do something, and then Yeah, maybe I can just do this. There we go. Okay. Just had to remind myself how to do that. Okay, so let's see. We want to see where I was parsing the event information. So let's see. Oh, I see what I did wrong. That's silly. Okay. Instead of set value, this should be set modulation. All right, let's try that again. Oh, by the way, in case you're wondering, the reason I have to delete the plugin in between stopping and restarting Bitwig is that I haven't implemented state saving and loading for the plugin yet, and for some reason, Bitwig doesn't like that very much. I don't fully know why. All right, so now we've got some modulation, and it's not having any impact on the frequency response, which is what we expect. So now let's re-enable the modulation, and we should see it work. So let's see. Oh wait, wrong. It was in grams, and let's see. And get modulated value. Yeah, this is where I had my other thing happening. So let's bring that back. And I think we should be all right. So let's try this out here. Hey, that looks about right. Cool, cool. So there we go. There's some parameter modulation in Chai. All right, I'm pretty happy with that. Cool. So yeah, I've been going for a little while here, so I'm probably gonna call it a day pretty shortly. But yeah, before I do, any last questions or things people are wondering about? All right, Chris is a fan. Yeah, let's get some resonance on that. That'll be more fun. There we go. Now it's dancing. Cool. Yeah. So I guess my next steps on this plugin, I don't know. I guess I need to implement state saving and loading. That's kind of a fundamental thing. Actually, I should be writing this down. Let's see. Let's see. SBF plugin. So here we go. To do state saving loading. Probably should at least take a look at how the audio port stuff is working, so I can see the channel count. So let's see, make the channel count more dynamic in some way in case someone loads it as like a mono plugin instead of a stereo plugin. Let's see. Oh, I should implement the reset function that Clap has. That would be good to do. And then probably the big one that everyone noticed is that there's no GUI. So yeah, maybe I'll implement the GUI. There's some ways to do that in Jai, but I haven't really looked at them yet. yeah, so I guess for those who don't know, Jai is primarily meant to be a programming language for developing games and video games. So this is maybe a little bit outside the intended use case, but if there's one thing that the language should be able to do, it's make a UI, right? So I'm sure it's possible. I just haven't spent any time looking at it because I'd rather look at the DSP stuff first. But yeah, I've been having some fun, just trying to get things working and experiment with everything. So yeah, maybe I'll do some more Jai stuff on the stream in the future, but I think probably next time I'll be going back to the other plugin that I've been working on in previous weeks. So yeah, that's about all I've got for now, unless folks have more questions. Happy to chat about whatever. George says plugins are basically games anyway. Yeah, that's that is true in a sense. Although I feel like, I mean, I don't know. I feel like there's a few differences in that, like, games have sound, but sound is usually not the priority. Whereas plugins have graphics, but graphics are usually not the priority. Whereas in games in games and plugins, that's kind of flipped, right? Where graphics are more or less prioritized and audio is more or less prioritized as well. George wants to talk about WDFs. Yeah, I was thinking about that this week, actually. I think the problem is I need like a thing for my plugin that is that needs like an interesting WDF, and then I can talk about WDFs. But I'll keep thinking about that. I'm sure there's a spot to fit that in. So yeah, maybe not next time, maybe the time after. I'll try to get a WDF thing prepared or ready to go in some way. Because yeah, I agree, it would be good to talk about WDFs. So yeah, thanks for reminding me. But cool, yeah. So I've got plugins working in Jai. Nothing particularly exciting just yet, but you know, stay tuned. Maybe there's something that'll come out of this that will be interesting. Actually, the other thing I haven't mentioned is that I do plan to make my my Jai bindings and my plugin base stuff open source. I just haven't done it yet. Yeah, I'm probably gonna clean up the folders and whatnot and try to document things a little bit better, and then I'll post things, and you know, hopefully other people who are interested can take a look at them and you know, have fun and make hopefully things that are even cooler than this. Yeah, that should be a fun time. But yeah, so if there's no more questions, I'm probably gonna call it a day here and get back to some other stuff that I was working on. But yeah, if there's more questions, I'm happy to talk as well. All right, let's give it another minute while I drink some water here. All right, well then I guess that about does it for me this week. So yeah, I'll see you guys. I don't know if it'll be next week or maybe the week after, but yeah, I'll see you guys again sometime soon. And so looking forward to it. And until then, hope everyone's doing well and has some fun. So all right, talk to you guys later.